Welcome back, guys. In this lecture we will be adding movement to our character so that when the player presses the left arrow on their keyboard, the character will move to the left, and if the player presses the right arrow on the keyboard, the character will move to the right. In order to achieve that, we will be writing a simple script. So go to this folder called scripts, right click and create a new C# script. Call it player controller, like this. Then double click to open this file up, and if you set up Visual Studio Code correctly, like I showed you in the last lecture, you should see the code popping up. And as you can see, when we create a new script, it comes pre-configured with a few things. Number one, it comes pre-configured with all the imports that we need for this particular script. And these are the same for all Unity scripts. And then you also have a class being created. As you can see, the class name is the same as our file name, player controller. And it is inheriting another class, mono behavior. And really, it's all about making this class work with Unity. And therefore, Unity has developed a lot of other features and a lot of other code that makes this particular class compatible with Unity engine. And so by inheriting all of these features, Unity makes it so that we don't need to care about any of that. We don't care about any of that, guys. We only care about exactly what kind of game logic we want to add to this class, and that's it. We don't care about anything else. Unity will fix everything else. And as you can see, we do have two functions here already. The first one is called start. So start is where we can set up some variables, and start will be running when this script is initiated. And then you also have update. Update is the function that will be running each frame. So your game will typically be running 60 frames per second, and this function called update will be executing 60 times per second. It will be executing each frame. So now that we know that, let's start coding our controls. The first thing we need to know is the speed. So we're gonna create a public float. Float is a number with decimals, and public means that we will be able to use our Unity editor in order to set this variable. It's gonna be very interesting because when we later connect this code to our jelly, you will be able to set this speed variable. Let's see, speed like this. You will be able to set this speed variable in the inspector. So that's quite cool. And speed will basically decide how fast our player is moving. When we press left or when we press right, how fast will the character move? So this is gonna be speed. Something else that is very important is that we need to control the movement of our character. So let's say that I know that the player presses the left arrow, and now I need to move this jelly to the left. How do I do that? Well, somehow I need to get hold of this rigid body, because rigid body is what allows me to move the character. So if I can apply force on rigid body, then I can move the character. So it's all about how can we connect this rigid body here to our script here. And to do that, first of all, we need to create a variable. So let's create private rigid body 2D. So the type of this variable is rigid body 2D, and the name of it is just gonna be it's gonna be a capital D. Name of it is just gonna be RB, like this, rigid body. And then we need to connect it to this rigid body, because I mean, for now this variable is empty. When we type like this, it is completely empty, it is uninitiated. So in the start method, we need to connect this variable to this particular rigid body. So how do you do that? Well, it's very easy. You go and you type rigid body, or RB, this variable right here, equal to get component, and then you get rigid body 2D, like this. So when we write like this, Unity will know, okay, then I need to go and I need to check what kind of rigid body this jelly has attached to it. and then I will put it in this variable, so that when we interact with this variable, we are interacting with this particular rigid body right here. So this is good. Now we need to create another function here called fixed update. So we're gonna go void fixed update. The difference between update and fixed update is that update is running each and every frame. So if you have a game that is running 60 frames per second, this function will be called 60 frames per second. Now, fixed update can be called each frame, it can be called 0 times per frame, or it can be called multiple times per frame. It all depends on how your physics engine is set up. So while update just blindly executes each frame, fixed update executes each physics step. So it's all about how your physics engine is set up, but fixed update will run each time your physics engine updates. So each time you have a tick in your physics engine. And so because we're interested in where the player is moving, and this is highly connected to the physics engine because the physics engine will move the player, we're dealing with fixed update and not update. So one thing we need to have is a variable called move input. Basically, does the player want to go to the left or to the right? Or does it want to stand still? So therefore we create a private float, move input. So it's gonna be a number with decimals, and it's gonna be either -1, it's gonna be 0, or it's gonna be 1. So when the input is -1, it means that we're moving to the left. If the input is 0, we're standing still. If the input is 1, we're moving to the right? So this is very important. And now we need to get this input from Unity. So on each physics tick, this function will be run, fixed update will be run, and here we need to ask Unity, okay, so is the player pressing some kind of button that should move our player? And it's very easy to do. You go input.get axis, and then you type horizontal, like this. What does it mean? Well, it means that if the player is playing this game on a PC and they're pressing the left arrow key, then this function will give -1, and it will put -1 into this variable. If the player is playing on a PC and they press the right arrow, then this function will put 1 in this variable, because you remember, -1 is to the left, 1 is to the right. And if it is the case that the player is playing on a PC and they do not press left nor right, then this function is gonna put 0 into this variable. Now, the cool thing with this function is the fact that it supports different platforms. You see, we're not specifically asking Unity whether the player is holding the right or the left button. We're not specifically asking that. Why? Because the player might be playing this on a PlayStation or Xbox, and then you don't have any keyboard. So if you're asking specifically for a keystroke, or you're asking specifically that whether the right arrow is being held or not, well, it means that if it is the case that you're doing that, it means that you're only supporting PC. You're not supporting mobile, you're not supporting PlayStation, you're not supporting other consoles. So therefore we use this special method, input get axis, and Unity will, under the hood, check which operating system and which device does this game run on. If it is PC and if it is keyboard, well, then it will look for left or right buttons, arrow buttons. If it is on Xbox, it will be looking for joystick tilting. So this is very cool. And so when we know if we're moving to the left or to the right, and just so that you remember, guys, -1 is left, 0 is still, 1 is right. So once we know that, we can actually start moving our player. We can make them move. So to make the player move, we need to manipulate this RB object, rigid body. So the way we do it is by writing rb.velocity. And velocity is a vector, meaning that you basically have an array of numbers, and this is a two-dimensional vector. So therefore we're writing vector 2 and we're creating a new object, so we need to write new vector 2. So it is a two-dimensional object because we are playing a two-dimensional game, we're creating a two-dimensional game, so therefore the vectors are going to be two-dimensional. And the first parameter into this function is, okay, how much force do we want to apply in the x direction? And in the x direction, we need to take the move input, -1, 0, or 1, and we need to multiply it by the speed. So if it is the case that the player is pressing the left arrow, it's going to be -1, and then we multiply it by the speed to make it even bigger. Maybe it's going to be -5 if the speed is 5. So in that sense, this rigid body will be pushed to the left with this force because it's a negative number. If it is the fact that the move input is -1 and is then multiplied by speed. Okay, cool. And the second argument is, okay, what kind of force do we want to apply to the y-axis? And we don't want to apply any special extra force. So we just take the velocity that this rigid body currently has on the y-axis, and we just copy it and we just keep it as it is, like this. Okay, so let's save this and let's go to our jelly here. And now we can actually connect this script to the jelly. So go to add component, and here you can write player controller, you will find it here, and add it. And as you can see, we can enter speed. You see, you have speed right here, and now you can enter it here in the editor. So let's enter 5, like this. So now if I go to jelly, it's gonna be 5 here. Let's run the game and see what happens, if we have actually succeeded or not. So if I press right, you see it moves, it moves to the right. If I press left, it moves to the left. So this is quite cool. But you see, it also rotates. It rotates a lot. Let's see if we can fix it easily. Let's see if we can fix it easily. So if I click on jelly and then I go to rigid body and I go to constraints, you see I can freeze rotation on the Z axis. So let's press that, let's run. Yeah, and now it doesn't rotate, but it moves left and right if I press left or right arrows. And it also moves left and right if I press A or D. So as you can see, Unity figures out that, hey, you can actually have several different ways of doing it. And of course, if I move off the platform, I will fall. So physics are working. Okay, guys, our character moves. The next step is to make our character jump. So I'll see you in the next lecture.